So resonance happens whenever you have a choice of where to put a double bond. Usually these molecules have oxygens on the outside, but sometimes you could have a different center atom and have sulfurs on the outside also. You know, O and S are in the same column. But there's a choice of where to put the double bond. It could be on the left or the right, like the top and bottom compounds. And really, you would expect the double bond to be shorter in this molecule than the single bond. But in reality, both bonds are the exact same size, and they're sort of somewhere between a single and a double bond. Because this extra pair of electrons, this pair that makes the double bond here, is called a pi bond. It's a bond that doesn't really change the geometry of the molecule. It doesn't change, you know, the shape of the molecule. It just pulls those two atoms closer together. And that pair actually flip-flops from here to here. So what happens is it's sort of like both of these bonds are a bond and a half. So they have, both of those bond lengths are identical lengths. They're somewhere between a double and a single bond. So what happens is sort of a rotation of the pairs. This top pair in this bond moves over to here. This one comes down here. This pair comes down here. And what that ends up making is, now you have this. You know, they sort of rotated. And then this pair moves over here, this comes down here, this shifts over here, and now you're back to what you started with on the top. And so there's just sort of this rotation of electrons. So in this molecule, sulfite, SO3 - 2, there's 3 places the double bond can be. And really the double bond, that extra pair of electrons, those pi electrons, flip back and forth. And so it's sort of like each bond is like a bond and a third. It's somewhere between a single and a double bond length also.